Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleo teacher, Jen, and it's time for Monday Musings. We are going to be talking about types of fossilization. So, not all fossils are created equal. There are different ways to fossilize organisms. And those different ways may or may not be better at fossilizing certain things than others. All right, so the most common way is through permineralization. This occurs when mineral-rich water percolates into the ground and fills in the spaces in the bones, shells, plants, etc., hardening and stabilizing the fossil. This same process can also replace the original organic material with minerals, which is called replacement. Often the two modes occur together and we call it petrification. Okay. Here I have an example of a permineralized bone. You can see that the spaces are filled in with crystals, quartz in this case, and you can see that it has totally been replaced and it's all rock. And of course, I have petrified wood here. So this wood still shows like the wood grain, but it's also very clearly rock. Another common method is natural molds and casts. This happens a lot with organisms made of calcite or aragonite, such as ammonites. So the ammonite gets buried, the matrix hardens, the shell dissolves, leaving behind the impression of the shell. And if I can get the lighting just right, you can actually see the ridges for the different chambers of this ammonite. So there's one side, here's the other side. So this is a natural mold. Now, sometimes that mold fills with a different sediment and hardens. This is a natural cast. So this here is a cast of a burrow. So something dug into the mud, left a hole, that hole filled with sand, and then the outside eroded away, and we were just left with the cast of the mold, of the burrow. Okay. Many plants are preserved through carbonization. The heat and pressure caused by burial preferentially removes the hydrogen and oxygen in the soft tissues and leaves behind the carbon as a black film. I've got a partially carbonized piece of wood from the Swift Formation. So this is a Jurassic Age tree. I'm going to put it up close so you can see, hopefully. There we go. So this actually still has some of the original wood, but I know that it's carbonized because it comes off on my fingers. It's not always a black film. This here is a leaf, and this is obviously soft tissue for a plant, and you can see when I put it up close that maybe. Okay, when I bring it up close, you can see the veins in the leaf here. So carbonization does a really good job of preserving those fine details that you normally wouldn't see. Now, less common is preservation that keeps the organic material. These would be fossils that are found in ice, like our little mammoth here, or amber, as in the case of this ant, or tar, as in this mammoth. These preserve the original organic material. Now, all of these are fairly recent. We can't really preserve things older than that. It just doesn't last long enough. But it happens that some of the new stuff we can get the original. And sometimes, if we are very, very lucky, we find fossils with exceptional preservation. We call those Lagerstätten, and some of the most famous sites include the Burgess Shale in Canada and the Solnhofen limestone in Germany. Now, there's two different types of Lagerstätten. There's Conservat Lagerstätten, which are the two that I just mentioned, where you get soft tissue preservation. And then you have what's called the Conzentrat Lagerstätten, which is an immense concentration of one thing. Here I have a trilobite from the Wheeler Formation, which is the second. It has a crap ton of Elrathia trilobites that are just preserved en masse. And I mean, as you can tell, it's in pretty good condition. Like, you can see a lot from this. If I flip it to the back side, you'll actually be able to see there's a itty bitty one. And it's harder to tell, but some of these smaller ones are actually a different type of trilobite. Pieces of those. There's another Elrathia right here. But yeah, so high concentration of trilobites that are well preserved. Now in the Conservat Lagerstätten, the preservation can be so good that the soft parts not only can be seen, but they can find things like melanosomes, which are pigment cells in the body, and we can even tell what color some of these things were, which is super impressive. Well, thanks for coming today and learning about different types of preservation. And make sure you tune in tomorrow for some preservation trivia. I will fossilize you later.